Good morning, students. Today we will discuss on the topic that is induction. So, what is induction? It is the phenomenon in which electric current is produced in a circuit or induced in a circuit due to the change in flux in its coil or nearby coil. So, that phenomenon we call as induction, right? So, induction on the ಯಾವುದಾದ್ರೂ ಒಂದು coil ಇರುತ್ತೆ, right? So, in this coil, the current is produced. So, ಈ coil ಅಲ್ಲಿ ಏನು produce ಆಗ್ತಾ ಇದೆ ನಮಗೆ current produce ಆಗ್ತಾ ಇದೆ. So, that is due to the flux which is generated in that coil. So ಈ coil ಅಲ್ಲಿ flux change ಆಯ್ತು ಅಂದ್ರೆ ಏನು produce ಆಗ್ತಾ ಇದೆ, current produce ಆಗ್ತಾ ಇದೆ, or the current which is produced in the another coil due to the change in flux in another coil, right? So ಈ coil ಅಲ್ಲಿ ನಮಗೆ produce ಆಗ್ತಾ ಇರೋ current that is due to the change in flux which is produced from the nearby coil. So ಈ coil ಅಲ್ಲಿ ನಮಗೆ magnetic flux produce ಆಗ್ತಾ ಇದೆ. So ಆ magnetic flux ಇಂದ current produce ಆಗ್ತಾ ಇದೆ ಯಾವ coil ಅಲ್ಲಿ, nearby coil, right? So that phenomenon we call as induction. So induction ಅಂದ್ರೆ ಏನು ಅಂದ್ರೆ it is a phenomenon in which current is generated or current is induced due to change in flux within its coil or nearby coil. So nearby coil ಅಲ್ಲಿ change in flux ಆಯ್ತು ಅಂದ್ರೆ ಕೂಡ ನಮಗೆ ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ, ಕರೆಂಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ. ಅಥವಾ ಸೇಮ್ ಕಾಯಿಲ್ ಅಲ್ಲಿ ಫ್ಲಕ್ಸ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಕೂಡ ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ, ಕರೆಂಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ. So that phenomenon we call as induction, right? So it is the phenomenon of electric current is induced in the coil due to change in flux by nearby coil. So current induce ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಜೊತೆಗೆ ನಮಗೆ EMF ಕೂಡ induce ಆಗ್ತಾ ಇದೆ, right? So we can take either electric current or EMF which is induced in a coil due to change in current, right? So say one coil ಇದೆ, ಈ coil ಅಲ್ಲಿ current induce ಆಗ್ತಾ ಇದೆ. So due to this current there is a induced in magnetic field. So current ಯಾವ ಇಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಫ್ಲೋ ಮಾಡ್ತಿರೋ current, that means ಕೊಟ್ಟಾಗ ಕರೆಂಟ್ ವೇರಿ ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಇಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಿರೋ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ this magnetic field again the current is induced in the conductor, or due to that magnetic field the another coil nearer by coil kuda namage produce ಆಗ್ತಾ ಇದೆ, current produce ಆಗ್ತಾ ಇದೆ, right? So that phenomenon we call as the induction, right? So if the coil has n turns, right? So coil ಅಲ್ಲಿ ಎಷ್ಟು ಟರ್ನ್ಸ್ ಇದೆ, ನಮಗೆ n turns ಇದೆ. So change in magnetic field. So from the definition electric current is directly proportional to the flux, right? So n pi is directly proportional to the current which is induced in the coil, right? So ಈ coil ಅಲ್ಲಿ ಎಷ್ಟು current generate ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದು ಯಾವ್ದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ, flux ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. So if the conductor having only one turn then n value is 1. So if the coil having number of turns, so hence we taken n pi, right? So this n pi, if we remove the proportionality constant, so that equals into some constant into I, right? So that constant we taken as inductance. So a constant ನಾವೇನಂತ ಕರಿತೀವಿ, inductance, right? So inductance, it is a scalar quantity. That means it has only the magnitude, right? So this inductance depends on the geometry of the shape of geometry, nothing but shape of the coil, right? Inductance depends on geometry of the coil and material of the coil. So ಅದು ಯಾವ ಮೆಟೀರಿಯಲ್ ಇಂದ ಮಾಡಿರ್ತಾರೋ ಅದ್ರ ಮೇಲೆ ಕೂಡ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಜೊತೆಗೆ ಶೇಪ್, ಸೊ ಶೇಪ್ ಮೇಲೆ ಕೂಡ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ, ಇಂಡಕ್ಟೆನ್ಸ್ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ further induction we have two types, right? So induction alli namage ಎಷ್ಟು types ಇದೆ? Two types. One is self induction and another one is mutual induction, right? So what is self induction means? So same coil alli current produce agtade, that means same coil alli flux change ಆಗೋದ್ರಿಂದ current produce ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಅದನ್ನ ನಾವು ಏನು ಅಂತೀವಿ? Self induction, right? So the current which is produced in the same coil or within its coil, so that we call as self induction. So mutual induction nothing but due to change in flux nearer by coil. So nearer by coil alli flux change ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಬೇರೆ coil alli current produce ಆಗ್ತಾ ಇದೆ, so ಅಂತ ಫಿನಾಮಿನಾ ನಾವು ಏನಂತ ಕರಿತೀವಿ? Mutual induction, right? So ಎರಡು ಕೇಸ್ ಅಲ್ಲಿ ನಮಗೆ n pi is directly proportional to I. So here also n pi is directly proportional to I. So ಇಲ್ಲಿ ನಮಗೆ only one coil ಇರುತ್ತೆ, so mutual induction ಅಲ್ಲಿ ನಮಗೆ ಎರಡು coil ಇರುತ್ತೆ, right? So here first we will discuss on self induction, then mutual induction, right? So self induction n pi, that is equals to, so that constant we take as L, right? So L into I, where L is a constant, so that constant we taken as self inductance, right? So ಇಲ್ಲಿ ಜನರಲ್ ಆಗಿ ಇಂಡಕ್ಟೆನ್ಸ್ ಅಂತ ತಗೊಂಡಿದೀವಿ. ಇಲ್ಲಿ ಎರಡು ಕೇಸಸ್ ಬರುತ್ತೆ, one is self inductance, mutual inductance. So only self inductance ನ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದ್ರೆ that constant we taken in the letter L, so L ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ, so that we call as self inductance, right? So what is self inductance? So self inductance is the ratio of the flux, so your flux, magnetic flux to the current flowing in the coil, right? So that gives what the definition of self inductance, right? So what is self inductance? So self inductance is the ratio of flux, so magnetic flux to the current flowing in the circuit, right? So that is L is equals to n pi by I. So here we can take inductance L. So self inductance, it is the ratio of magnetic flux to the current flowing in the circuit, right? So induction ಬೇರೆ, inductance ಬೇರೆ. Induction ಅಂದ್ರೆ phenomenon, right? So inductance ಅಂದ್ರೆ it is the ratio of magnetic flux to the current flowing in the circuit, right? So inductance ಅನ್ನೋದು ನಮಗೊಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ, so that is the proportionality constant, right? So where pi is the flux, that is the magnetic flux. So last ನಾವು ಡಿನೋಟ್ ಮಾಡ್ಕೊಂಡಿದ್ವಲ್ಲ pi b, so ಜನರಲ್ ಆಗಿ ನಾವು pi ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಂತೀವಿ, right? So it's SI unit Henry, ಅದನ್ನ ವರ್ಡ್ಸ್ ಅಲ್ಲಿ ಬರೆದ್ರೆ ಹೆನ್ರಿ, ಸೊ ಲೆಟರ್ ಅಲ್ಲಿ ಬರೆದ್ರೆ ಕ್ಯಾಪಿಟಲ್ H. Next, dimension. So dimensions of self inductance, right? There is m L square t power minus 2 a power minus 2. So that is again we are going to write the dimensions by using SI unit. So SI unit na itkondu ನಾವು dimensions na ಬರಿತಾ ಇದೀವಿ. So why? Because L is equals to n pi by I. So n ಅನ್ನೋದು constant, pi is the magnetic flux. So we have the relation pi is equals to B into A, right? So where A is area and B is the magnetic field, right? So magnetic field ke relation ಏನಿದೆ, from the Lorentz force F is equals to QVB. So from that we can write B is equals to F divided by QV, right? So here F is the force, B is the velocity, Q is the charge, right? So charge ge namage yavade ತರ dimensions illa. Again by using the relation I is equals to Q by T. So from that we can write Q is equals to I into T. So substitute here F divided by I into T into B. So that gives what? B. So again substituting here phi, that is equals to F ITV into A, right? So for the inductance it is 4 divided by I, right? We can write L, that is equals to FA divided by I square TV. So SI unit ಬರುತ್ತೆ ಇದಕ್ಕೆ kg meter per second square, area ಗೆ meter square, so current ಗೆ ampere square, time ಗೆ second, so velocity ಗೆ meter per second, right? So second get cancelled, so meter get cancelled, so remaining kg meter square per second square per ampere square, right? So ಅದನ್ನ dimensions ಬರೆದ್ರೆ kg ಗೆ meter, kg ಗೆ mass ಮತ್ತೆ meter ಗೆ length, time ಗೆ second ಗೆ time ಮತ್ತೆ current ಗೆ amperes. So dimensions ಅಲ್ಲಿ ಕೂಡ amperes ಗೆ a ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿರೋದ್ರಿಂದ so ಇಷ್ಟು lengthy procedure ಇದೆ. So directly you need to remember this one, right? So this is about the induction, right? So if you want to find the value of induction in a solenoid, right? Inductance, that is self-inductance in a solenoid. Right? So consider a solenoid of length L, right? So consider a solenoid of length L and area of cross section is A. So where A is the area of cross section and L is the number of turns per unit length, right? So here we are taken small n, right? So L is the length of solenoid, right? So A is the area of cross section of solenoid and small n is the number of turns per unit length, right? So if you write in terms of capital N, that is equals to N into L, right? So from the induction theory, when the current is flowing in the coil, right? So we have the relation N pi, that is equals to L into I, right? So we call this one as the first equation, right? Now when the current is flowing in the coil, so current ಯಾವುದಾದ್ರೂ ಒಂದು coil ಅಲ್ಲಿ flow ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ here it produces the magnetic field, right? So here it generates the magnetic field. So ಇದು ನಮಗೆ solenoid ಇರೋದ್ರಿಂದ, so magnetic field in a solenoid, again from the previous chapter moving charges and magnetism, right? So the magnetic field in the solenoid due to current I, right? So current flow ಆಗ್ತಾ ಇದೆ solenoid ಅಲ್ಲಿ, so magnetic field produce ಆಗ್ತಿದೆ, so that we written B is equals to mu naught N I, where N is the number of turns per unit length and I is the current which is flowing in the solenoid, right? Next, as the magnetic field is produced in the solenoid, so ಇಲ್ಲಿ ಏನು produce ಆಗ್ತಾ ಇದೆ ನಮಗೆ magnetic field produce ಆಗ್ತಾ ಇದೆ, right? So in the solenoid magnetic field is produced, right? So due to this magnetic field, again here EMF is induced. So ಇಲ್ಲಿ magnetic field produce ಆಗ್ತಿರೋದ್ರಿಂದ it links with the conductor, right? So due to this magnetic field, EMF is induced in the solenoid, right? So that's we call as self inductance. So ಇದರಲ್ಲಿ ಏನು produce ಆಗ್ತಾ ಇದೆ, so same coil ಅಲ್ಲಿ ನಮಗೆ EMF induce ಆಗ್ತಾ ಇದೆ, so that we call as self inductance, right? So here EMF is produced due to this magnetic field, right? EMF is induced in the solenoid, right? So that we written E, that is equals to minus from the previous topic, right? So induced EMF, right? So E is equals to minus d of N pi divided by dt, that is d pi by dt. So here we have N number of turns, so hence we taken N pi, right? So from this, so we can write E is equals to minus d by dt. So from the first relation, N pi na namen baribodu L into I, right? So d by dt of L into I. So where L is a constant, so we can take outside. So induced EMF E, that is equals to minus L di by dt, right? So this is the EMF which is induced in the solenoid, right? So that is L is the self inductance and I is the change in current with respect to time. So this EMF is also called back EMF, right? So EMF which is produced in the same coil due to the magnetic field. So this magnetic field is produced by the current I. So ಇದರ flow ಆಗ್ತಾ ಇರೋ current ಇಂದ ನಮಗೆ magnetic field produce ಆಗ್ತಿದೆ. So produce ಆಗಿರೋ magnetic field ಇಂದನೇ ನಮಗೆ ಏನು produce ಆಗ್ತಾ ಇದೆ, EMF produce ಆಗ್ತಾ ಇದೆ, right? So that is here we are getting minus symbol. So minus ಏನು represent ಮಾಡುತ್ತೆ ಅಂದ್ರೆ again from the Lenz's law. So it opposes the change in current in the coil, right? So minus indicates what? Opposes the change in current in the coil. Hence we call that one as back EMF, right? So back EMF, it opposes the change in current in the coil or in the solenoid, right? So nothing but simple words alle idodalla, inductance is nothing but the opposition, right? So that is nothing but the resistance. So idu oppose ಮಾಡ್ತಾ ಇದೆ, ಏನನ್ನ oppose ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ to change in current. So change in current is either increase of the current or decrease of the current. So current increase ಆಗೋದು ಮತ್ತೆ decrease ಆಗೋದನ್ನ control ಮಾಡ್ತಾ ಇದೆ. So hence we call that one as back EMF, right? So back EMF is E, that is equals to minus L di by dt. So this opposes the change in current, right? So next, so here EMF is producing. So EMF produce ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ again flux is linked with the same coil. So that means here the flux is generated, right? So that flux is relates with the coil, right? So that we written as N pi, right? So N pi means pi is the flux which links with the number of turns, hence we taken N pi, right? So that is equals to change in flux linked with the coil, that is again given by the relation. So your relation on the magnetic field, right? So flux ಮತ್ತು magnetic field relation ಹೇಗಿದೆ, pi is equals to B into A, where B is the magnetic field produced and A is the area of the coil, right? So N pi that is equals to B into A, right? So B, here we have the value mu naught Ni into A, right? So from the induction, right? So N pi, we can replace I to the LHS, N pi by I, that is equals to mu naught N A, right? So this be written as L. L is equals to mu naught N. So this is the inductance in case of solid. So the value of L in solenoid, right? So inductance in solenoid, right? So idu namge final relation, right? So here we can reduce the back EMF and also we can find the value of L, right? So 3 marks get derivation irutte. So to find the value of L, that is inductance in a coil or inductance in a solenoid, right? So again SO unit Henry ಮತ್ತೆ dimension. So inductance ಗೆ ಏನು ಯೂನಿಟ್ ಇರುತ್ತೋ ಅದು self inductance ಮತ್ತೆ mutual inductance ಎರಡಕ್ಕೂ ಕೂಡ ನಮಗೆ ಸೇಮ್ ಇರುತ್ತೆ, right? So this one is the self inductance, right? So ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಆಯ್ತು ಅಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಮ್ಯೂಚುವಲ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಗೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ನೆಕ್ಸ್ಟ್ EMF ಏನ್ ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಕರೆಂಟ್ ನ ಅಪೋಸ್ ಮಾಡ್ತಾ ಇದೆ. ವ್ಯಾಲ್ಯೂ ಆಫ್ I should be increase ಮತ್ತೆ ಡಿಕ್ರೀಸ್ ಆಗೋದನ್ನ ಅಪೋಸ್ ಮಾಡ್ತಾ ಇರೋದ್ರಿಂದ ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ we have to done to supply the current. So in coil ಅಲ್ಲಿ current flow ಆಗಬೇಕು ಅಂದ್ರೆ we need to supply some external current, right? So external current ನ supply ಮಾಡಿದ್ರೆ that balances what the back EMF, hence the current is easily flowing or easily circulate in the coil, right? So due to the back EMF, so work is done. So your work namge external work done, that means we need to supply the current externally, we need to supply the current, right? So that power is equals to E into I, that means V into I, that we given as power, that is equals to modulus of E into I, that means magnitude of E. So magnitude of E nothing but we taken the positive value, right? So this power is what the rate of change of work done, right? So that we can write dW by dt. So power is written by rate of change of work done, right? So dW by dt, that is equals to again from the back EMF. So this is modulus of E, we can write L into di by dt into I. So in the LHS we have dt, RHS we have dt, so get cancels. So dW is the small work done, Li di, right? So the total work done W, that is equals to integration of dW, right? So integration of Li di. So in place of dW we can write Li di, right? So L is a constant, we need to integrate I with respect to di, right? So L into I square divided by 2. So this is the work done. So this work done is stored as mechanical energy. So e solenoid ಒಳಗಡೆ ನಮಗೆ energy store ಆಗುತ್ತೆ. So that work done is stored as the energy, right? So that is W is equals to U. So hence U is equals to half Li square, right? So this is similar to that of the kinetic energy, half m v square, right? So in case of capacitor also we discussed half C V square, right? Where C is the capacitance of a capacitor and V is the voltage. So same as we are also half L is the inductance of the inductor and I is the current flowing in the circuit or current flowing in the coil, right? So idu namge 3 marks ge tumba important, right? So energy stored in an inductor. So inductor, solenoid, coil ಏನು ಬೇಕಾದರೂ ಅದನ್ನ ಮೆನ್ಷನ್ ಮಾಡ್ಕೋಬಹುದು, right? So inductor or solenoid or coil. So why we are going to take on power means external work we need to apply. So now ಹೊರಗಡೆಯಿಂದ ಇದಕ್ಕೆ ವರ್ಕ್ ಮಾಡಬೇಕು. That means external work is nothing but externally we are supplying the current. That means externally we are applying the power, right? So why? Because power means there is change in current. So current ಏನಾಗ್ತಾ ಇದೆ ನಮಗೆ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ. ಅದನ್ನ ಯಾವುದು ಅಪೋಸ್ ಮಾಡ್ತಾ ಇದೆ? Back EMF. That is the EMF which is induced in the coil due to the magnetic field, right? So this is from the definition. From first year we have the relation between power and work done, right? So power is equals to energy by time. So energy is equals to work done, right? So energy ಮತ್ತು work done ಎರಡು ಸೇಮ್ ಇರೋದ್ರಿಂದ change in work done to the time taken, right? That is equals to again from the relation induced EMF L di by dt into I. So this is similar. Energy U is equal to half Li square, right? So U is equal to half CV square. Again, U is equal to half MV square. So ಇವೆಲ್ಲವೂ ಕೂಡ ನಮಗೆ energy relations. So this is L in case of inductance. So C, that is in case of capacitance. So capacitor ಅಲ್ಲಿ ನಾವು ವೋಲ್ಟೇಜ್ ನ ಸಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವಿ. So ಇಂಡಕ್ಟರ್ ಅಲ್ಲಿ ನಾವು ಕರೆಂಟ್ ನ ಸಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವಿ, right? ಸೊ ಇಲ್ಲಿ ಏರಿಯಾ ವ್ಯಾಲ್ಯೂ ನಮಗೆ ಸೊಲೋನಾಯ್ಡ್ ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ ಕ್ರಾಸ್ ಸೆಕ್ಷನಲ್ ಏರಿಯಾ, ಸೊ ಸರ್ಕ್ಯುಲರ್ ಶೇಪ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಸೊ ಏರಿಯಾ ಆಫ್ ಎ ಸರ್ಕಲ್ ದಟ್ ಈಸ್ ಪೈ ಆರ್ ಸ್ಕ್ವೇರ್, ರೈಟ್? ಸೊ ಇಫ್ ಯು ರೀಪ್ಲೇಸ್ ದಿಸ್ ಒನ್, ಎಲ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಮ್ಯೂ ನಾಟ್ ಎನ್ ಪೈ ಆರ್ ಸ್ಕ್ವೇರ್. ಸೊ ಇದನ್ನು ಕೂಡ ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ರಿಲೇಷನ್ ಬರ್ಕೋಬಹುದು, ರೈಟ್? So solenoid always in the circular form, hence we can take the area of the circle. So ಇದು ಯಾವುದು ನಮಗೆ rectangular shape ಅಲ್ಲಿ ಇರೋದಿಲ್ಲ. So ಎಲ್ಲವೂ ಕೂಡ coils wound ಆಗಿರೋದ್ರಿಂದ solenoid is in a almost circular shape ಇರುತ್ತೆ, right? Where r is the radius of the solenoid. So next, mutual inductance. So mutual inductance like the current which is flowing in one coil and due to the change in flux it induces the current in the another coil. So one coil ಅಲ್ಲಿ current flow ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಇನ್ನೊಂದು coil ಅಲ್ಲಿ current produce ಮಾಡ್ತಾ ಇದೆ. So ಅಂತ ಫಿನಾಮಿನಾ ನಾವು ಏನಂತ ಕರಿತೀವಿ? Mutual inductance, right? So consider one solenoid. So one solenoid ಒಳಗಡೆ ಇನ್ನೊಂದು solenoid ಇರುತ್ತೆ, right? This is the axis of the solenoid. So inside solenoid we taken that one as S1 and outside solenoid we taken that one as S2, right? So this is the axis of solenoid and R1 is the radius of the first solenoid and R2 is the radius of the second solenoid, right? So ಎರಡರದ್ದು ಕೂಡ length ನಮಗೆ ಏನಿರುತ್ತೆ same. L is the length of the two solenoids. So ಎರಡು solenoid length ಏನಿರುತ್ತೆ same ಇರುತ್ತೆ, but number of turns ಏನಿದೆ ನಮಗೆ different ಇದೆ, right? So hence we taken N1 is the number of turns per unit length in solenoid S1 and N2 is the number of turns in the solenoid S2, right? So R1 is the radius of first solenoid and N1 is the number of turns per unit length in first solenoid, right? So R2 is the radius of the second solenoid and N2 is the number of turns per unit length in second solenoid, right? So again in this case also N pi is directly relates with the current, right? So change in magnetic flux is directly relates with the current, right? So ಇಲ್ಲಿ ನಮಗೆ change in magnetic flux ಇರಬೇಕು. So first we taken current I2, right? So current I2, that is current which is flowing in the second solenoid, right? So ಈ second solenoid ಅಲ್ಲಿ current flow ಆಗ್ತಾ ಇದೆ. So current flow ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ? Magnetic field produce ಆಗುತ್ತೆ. So that magnetic field is linked with the first solenoid. So hence the current is induced in the first solenoid, right? So second solenoid ಅಲ್ಲಿ ನಾವು current supply ಮಾಡಿದ್ರೆ first solenoid ಅಲ್ಲಿ ಏನು generate ಆಗ್ತಿದೆ ನಮಗೆ current generate ಆಗ್ತಾ ಇದೆ, right? So that's why N1 pi 1, that is the flux which is linked with the first solenoid, hence we taken N1 pi 1. So pi 1 is the flux which is linked with the first solenoid, that is directly relates with the current which is flowing in the second solenoid, right? So that is N1 pi 1, that is equals to that is directly proportional to I2, right? So N1 pi 1, that is equals to M12 I2, right? So where M12 is the mutual inductance of S1 with respect to S2, right? So self inductance ಗೆ L ಅಂತ ತಗೊಳ್ತಾ ಇದೀವಿ, mutual inductance ಗೆ M ಅಂತ ತಗೊಳ್ತಾ ಇದೀವಿ, right? So M12 is the mutual inductance of first solenoid with respect to second solenoid, right? So we can take this one as first relation. So as the current is flowing in the second solenoid, so hence magnetic field produced in the solenoid S2. So ಯಾವ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇದೋ, ಸೊ ಆ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ನಮಗೆ ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ಇದು ಸೊಲೋನಾಯ್ಡ್ ಇರೋದ್ರಿಂದ ಅಗೇನ್ ಫ್ರಮ್ ದ ರಿಲೇಷನ್ B2. So where B2 is the magnetic field which is produced in the second solenoid, that is equals to, so solenoid the magnetic field formula is B2 is equals to mu naught N2 I2, right? So ನಮಗೆ solenoid the formula is B is equals to mu naught Ni, right? So B is the magnetic field, N is the number of turns per unit length and I is the current flowing in that solenoid. So ಯಾವ್ದ್ರಲ್ಲಿ magnetic field produce ಆಗ್ತಾ ಇದೆ? Second solenoid, right? So that's why we taken B2. N2 number of turns in the second solenoid, so hence we taken N2. So ಯಾವ್ದ್ರಲ್ಲಿ current flow ಆಗ್ತಾ ಇದೆ? Second solenoid ಅಲ್ಲಿ current flow ಆಗ್ತಾ ಇದೆ, so hence we taken I2, right? So now here due to this magnetic field, the flux which is linked with the coil, right? So ಇಲ್ಲಿ magnetic field produce ಆಗ್ತಿದೆ, due to that magnetic field the flux which is linked with the first coil, right? Magnetic flux links with the solenoid S1, right? So ಯಾವ magnetic field B2, that means flux linkage ಅಂತ ನಾವು ಕರೀತೀವಿ ಅಥವಾ flux links with the solenoid S1, right? So again from the formula of the flux pi, that is equals to B into A, right? So N1 pi 1, that is it, hence we taken N1 pi 1. So ಯಾವ flux link ಆಗ್ತಾ ಇದೆ, B2 flux link ಆಗ್ತಾ ಇದೆ, right? So NBA, right? So N2 into L. Why? Because we have N number of turns, so hence we taken into L, right? So into B, so B is mu naught into I2, right? So again area A. So from this N1 pi 1, that is equals to mu naught N1 into L A I2, right? So calling this one as second equation, right? So from equation 1 and equation 2, right? From equation 1 and 2. So from equation 1 and 2, LHS ಅಲ್ಲಿ ಎರಡು ನಮಗೆ ಏನಿದೆ ಸೇಮ್ ಇದೆ. So RHS ಅಲ್ಲಿ M12 ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಏನಿದೆ ನಮಗೆ mu naught N1 into L into A ಇದೆ. So again in place of I2 we having I2, right? So from equation 1 and 2, that means comparing equation 1 and 2, we can write the mutual inductance M12. So mutual inductance of S1 with respect to S2, that is M12, that is equals to mu naught N1 into L into A, right? So we can take this one as third equation, or I will write here M12, that is equals to mu naught N1 into L into A. Third relation. Right? Where N1, N2 are the number of turns per unit length in solenoid 1 and solenoid 2, right? So next, ಇದು ನಮಗೆ first case, right? So first case ಅಲ್ಲಿ ಏನು ಮಾಡಿದ್ವಿ, second solenoid ಗೆ current flow ಮಾಡ್ತಾ ಇದ್ವಿ, right? So now in the first case, sorry, in the second case, current I1 which is flowing through the first solenoid. So first solenoid ಅಲ್ಲಿ current ನ flow ಮಾಡ್ತಾ ಇದೀವಿ. So here the magnetic field is produced. So due to this magnetic field, it links with the second coil and hence current is induced in the second coil, right? So first case ಅಲ್ಲಿ ನಾವು second solenoid ಗೆ current ನ pass ಮಾಡಿದ್ವಿ. So in the second case we are supplying the current to the first solenoid. So first solenoid ಅಲ್ಲಿ current flow ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ here it produces the magnetic field. So that magnetic field links with the second coil, right? So hence the current is flowing in the second coil, right? So here we can change the flux which links with the second coil N2 pi 2, right? So due to which current? That is due to the first current. So hence we taken that one as I1, right? So N2 pi 2 is the flux linkage with the second coil due to the current which is flowing in the first coil, right? So if you remove the proportionality here, we can take M21, right? So M21 is the mutual inductance of the second solenoid with respect to first solenoid, right? So M21 S2 with respect to S1, right? So now the current is flowing in the first solenoid, hence the magnetic field produced in the first solenoid, right? So the magnetic field is produced in the first solenoid S1, so that is given by B1 mu naught N1 and I1, right? So due to this magnetic field which links with the second solenoid, right? So links with the second solenoid S2, that is N2 pi 2, right? That is equals to number of turns N1 L, here it is N1 I1 into A, right? So again, so here it is N2 pi 2 I1. Right. So now again multiply here mu naught N1 into L into A into I1, right? So compiling equation again, here it is N2 pi 2. So compiling equation 1 and 2. So from this we can write M21, right? So M21 is mu naught N1 into L into A, right? So M21, that is equals to mu naught N1 into L into A. We call that one as the fourth equation, right? So comparing equation 3 and 4. So RHS ಅಲ್ಲಿ ಎರಡು ವ್ಯಾಲ್ಯೂ ಸೇಮ್ ಬರ್ತಾ ಇದೆ ನಮಗೆ, ಸೇಮ್ ಬರ್ತಾ ಇದೆ. So hence we can take M12 is equals to M21, that is in general we can take M, that is the mutual inductance, right? So from this we can write M again the mutual inductance, that is equals to, right? So here we can take M21 or M12. So from this we can define the relation mutual inductance M12, that is M21, that is equals to N1 pi 1 divided by I2. By I1 or M12, that is equals to N1 pi 1 divided by I2, right? So these two are the mutual inductance of the second solenoid with respect to first one. So this is the mutual inductance of the first solenoid with respect to the second one. So in general, if we define for the mutual inductance, right? So it is the ratio of flux, right? So that is the magnetic flux to that of the current which is flowing in another coil, right? So where phi 2 is the flux which is generated in the second coil, but I1 is the current which is flowing in the first coil, right? So here also mutual inductance is defined as the ratio of the flux which is generated in the first coil due to the current which is flowing in the another coil, right? So that is what the definition of mutual inductance, right? So mutual inductance is defined as the ratio of the magnetic flux to the current flowing in another coil or another conductor or another solenoid, right? So that is what the definition of mutual inductance, right? So it is the ratio of flux, that is magnetic flux to the current flowing in another coil. Through a nearby coil ಅಲ್ಲಿ current flow ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ, so another coil ಅಲ್ಲಿ produce ಆಗ್ತಾ ಇದೆ ನಮಗೆ magnetic flux produce ಆಗ್ತಾ ಇದೆ, where M is a constant. So here also the unit is same. So SI unit is Henry. So that is H. So it is the opposition which is offered to the change in current in the solenoid, right? So that is nothing but the resistance. So conductor ಅಲ್ಲಿ ಯಾವ ತರ resistance ಇರುತ್ತೋ ಅದೇ ತರನೇ ನಮಗೆ inductor ಅಲ್ಲಿ inductance ಇರುತ್ತೆ. So this is the intrinsic property of an inductor, which opposes the change in current in the solenoid, right? So its SI unit is Henry. So 2 marks get ಈ ಟಾಪಿಕ್ ಅಲ್ಲಿ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ಮೊನ್ನೆ ಸಪ್ಲಿಮೆಂಟರಿ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಇದ್ರ ಮೇಲೆ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಕೇಳಿದ್ದಾರೆ, ಐದರ್ ಇನ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಆರ್ ಇನ್ ಮ್ಯೂಚುವಲ್ ಇಂಡಕ್ಟೆನ್ಸ್, ರೈಟ್? ಸೊ ಆಲ್ಮೋಸ್ಟ್ ನಮಗೆ ಎನರ್ಜಿ ಮೇಲೆ ಕೇಳಿರ್ತಾರೆ, ಸೊ ಎನರ್ಜಿ ಇನ್ ಆನ್ ಇಂಡಕ್ಟರ್. ಸೊ ಲಾಸ್ಟ್ ಟಾಪಿಕ್ ಒಂದು ರಿಮೈನ್ ಇದೆ, ದಟ್ ಈಸ್ ದ ಜನರೇಟರ್. ಸೊ ಅದು ಕೂಡ ರೆಗ್ಯುಲರ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ, ಸೊ 5 marks ಗೆ ಎಸಿ ಜನರೇಟರ್, right? So the complete ಆಯ್ತು ಅಂದ್ರೆ ಈ ಚಾಪ್ಟರ್ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ. So we continue in our next class.